Have you ever thought about how you'd build a totally private, secure fortress right in the middle of a huge, bustling public square? Well, that's kind of the challenge we face in the cloud. And the solution? It's one of AWS's most foundational services, the Virtual Private Cloud, or VPC. So, let's dive in and see exactly how it works. So, this is really the big question, isn't it? I mean, with millions of other people and companies on AWS, how do you actually carve out your own little corner that's completely separate and totally under your control? How do you build that fortress for your applications and your data? And the answer is the Amazon VPC. Now, to make this whole thing super simple, let's use an analogy. I want you to think of your VPC as your own private, high-end cloud kitchen. You get to decide the entire layout, you pick the IP address range, you control who comes in and out. You have complete and total control over your networking environment. All right, so let's step inside our brand new cloud kitchen. What are the key pieces we need to set up before we can even think about cooking or, launching our apps? Well, every great kitchen has its essential parts, right? And our VPC, we've got subnets. Think of these as our individual workstations. We've got route tables, which are basically the traffic rules for the whole kitchen. Then there are internet gateways. That's the main door to the outside world. And finally, we have two layers of security. Security groups, which are like personal bodyguards, and NACLs, which are like checkpoint security for entire sections of our kitchen. Okay, first things first, let's talk about getting organized. A messy kitchen is a slow kitchen, and it's probably not very secure either. In our VPC, the way we keep everything neat and tidy is by using something called subnets. So what are subnets, really? Just think of them as the different stations in your kitchen. The prep station over here, the grill line over there, the pastry corner in the back. They're just distinct segments inside your VPC, and each one lives in a specific AWS availability zone. This is how you organize all your resources, like your servers and databases, and it adds some really crucial layers of security. And this brings us to the two main flavors of subnets. First, you've got your public subnets. These are like the front of house of your restaurant. They're accessible from the internet, which makes them perfect for things like your web servers. And then you have private subnets. This is the secure backend, where you keep all your valuable stuff, like your databases, totally shielded from any direct access from the internet. Okay, so our kitchen is organized into different workstations. Awesome. But now we need to figure out the pathways. How do requests get in from the outside world? And how do our internal systems talk to each other and get back out to the internet? So first up, we need a door. That's the Internet Gateway, or IGW for short. You can think of it as the one and only main entrance and exit for your entire kitchen. It's the single bridge that connects your private VPC to the huge public internet, letting traffic flow both in and out. Now, just having a door isn't enough. You need rules about who can use it and where they can go. That's where route tables come in. Think of these as the kitchen manager giving very specific instructions to the staff. Every single subnet has a route table that basically acts like a GPS, telling all the network traffic exactly where it's supposed to go. So let's actually trace the path. Let's say a request starts inside a public subnet, maybe from a web server trying to get an update. The first thing it does is check its local route table for directions. That table has a super important rule. You see it here as 0.0.0.0/0. That's just a fancy way of saying any traffic that's trying to go anywhere outside of our kitchen. That rule points the traffic straight to the internet gateway, and boom, just like that, it's out on the public internet. Okay, we've got our layout, we've got our traffic flow, but what about security? This is without a doubt the most critical piece of the puzzle, especially if you're studying for a certification exam. Our cloud kitchen needs some serious security. First up are security groups. I want you to picture these as a personal bodyguard that you assign to each and every resource, like your EC2 instances. It's a virtual firewall that wraps itself right around that instance and decides precisely what traffic is allowed in or out. Now listen up, because this is the most important part. Security groups are stateful. You are going to see this term again, I promise. Stateful means they have a memory. If you make a rule that allows a request in, the security group automatically remembers that connection and allows the response to go back out. You don't need a second rule. It's like a bodyguard who lets someone into a party and remembers their face so they can just walk right back out without getting stopped again. Now for our second layer of defense, we have network access control lists, or NACLs. So if a security group is a personal bodyguard, a NACL is like the checkpoint security guard, standing at the entrance to an entire section of the kitchen, the whole subnet. It inspects every single packet of traffic trying to get into or out of that entire area. And here is the huge difference. NACLs are stateless. Unlike our smart bodyguard, this guard has zero memory. What does that mean? It means you have to explicitly create rules for traffic going in and for traffic going out. If you make a rule to allow a request to come in, you have to make a totally separate rule to allow the response to go back out. This guard checks your ID on the way in and then makes you show it all over again on the way out. So look, this table right here, this is your ultimate cheat sheet. Let's break it down. Security groups are at the instance level. They're stateful, and they only have allow rules. NACLs are at the subnet level. They're stateless, and they have both allow and deny rules. Seriously, understanding this difference is absolutely critical for getting VPC questions right on the exam. All right, let's bring this all home. If you are studying for an AWS certification right now, this is for you. This is the rapid-fire review of what you absolutely positively have to remember. First up, the core ideas. A VPC is your private, isolated section of the cloud. You use subnets to break it up and organize everything. What makes a subnet public? It has a route to an internet gateway. A private one? It doesn't. Simple as that. And second, security. This is the big one. Security groups are those stateful bodyguards for your instances. NACLs are the stateless guards for your subnets. If you only take one single thing away from this entire explainer, please let it be the difference between stateful and stateless. I guarantee it will come up. So there you have it. We've designed our VPC, we've organized our workstations with subnets, we've set up all the traffic rules, and we've hired our security guards. We have built our cloud kitchen from the ground up. So the only question left is, are you ready to fire up the console and actually start cooking?